Chapter number 5. Squares and square roots. Squares. The square of a number is the product of the number with the number itself. For example, A. The square of 4 is 4 square equals to 4 multiplied by 4 equals to 16. B. The square of 9 is 9 square equals to 9 multiplied by 9 equals to 81. Square numbers or perfect squares. A natural number x is called a perfect square or a square number if it is the square of some natural number, that is x equals to y square. For example, we know that 4 equals to 2 square, 25 equals to 5 square, 64 equals to 8 square, and so on. Thus 4, 25, 64, etc. are perfect squares. Example 1. So, to find the number whose square is 144, we need to find the prime factors of 144. The prime factors of 144 are, so we find the prime factor, so dividing by 2, 72, again divide by 2, we get 36, again by 2 we get 18. Now when 18 is divided by 2 we get 9. Now it is not divisible by 2, so we divide by 3, 3 3s are 9, and at last again 3 1s are 3. So these are our factors 2, 2, 2, 2, 3, 3. So we can write 144 as the product of prime factors 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. So now let's construct a pairs of similar factors. So we have constructed the pairs, they are in pairs form, so we can also write 144 equals to 2 square multiplied by 2 square multiplied by 3 square, which is equal to 12 square. So the number whose square is 144 is 12. So here we express 144 as the product of pairs of equal factors, that is 2 multiplied by 2, 2 multiplied by 2, and 3 multiplied by 3. So we have got 3 pairs. So we write 2 to the power 2, 2 to the power 2, and 3 to the power 3 in product equals to 12 square. Hence 12 is the number whose square is 144. As 144 can be expressed as the product of pairs of equal factors. 144 can be expressed as the product of pairs of equal factors. As the product of pairs of equal factors, it is a perfect square. So 144 is a perfect square. Properties of perfect squares. Property 1. A number ending in 2, 3, 7 or 8 is never a perfect square. For example, the numbers 33, 217, 538, etc. end in 3, 7 and 8 respectively. Hence these are not perfect squares. Property 2. A number ending in an odd number of zeros is never a perfect square. The numbers 180, 64,000, 33 lakh and in 1 0, 3 0 and 5 zeros respectively, hence these are not perfect squares. Property 3. If a number when divided by 3 leaves a remainder 2, then it is not a perfect square. For example, 170, 578, 617, 722, etc. Property 4. If a number when divided by 4 leaves a remainder 2 or 3, then it is not a perfect square. For example, 578, 654, 798, 1002, etc. Property 5. The square of an even number is always even. For example, 12 square equals to 144, 14 square equals to 196, 16 square equals to 256, 20 square equals to 400, etc. Property 6. The square of an odd number is always odd. For example, 11 square equals to 121, 13 square equals to 169, 15 square equals to 225, 17 square equals to 289, 19 square equals to 361, etc. Property 7. The square of a proper fraction is smaller than the fraction. For example, 2 by 3 whole to the power 2 equals to 2 by 3 into 2 by 3 equals to 4 by 9, and 4 by 9 is less than 2 by 3, 4 multiplied by 3 is less than 9 multiplied by 2. Property 8. For every natural number n, we have n plus 1 whole square minus n square equals to n plus 1 plus n multiplied by n plus 1 minus n equals to n plus 1 plus n. Therefore, n plus 1 whole square minus n square equals to n plus 1 plus n. For example, a. 36 square minus 35 square equals to 36 plus 35 equals to 71. B. 89 square minus 88 square equals to 89 plus 88 equals to 177. Property 10. Pythagorean triplets. Three natural numbers a, b, c are said to form a Pythagorean triplet. A, b, c if a square plus b square equals to c square. For every natural number a greater than 1, we have 2a, a square minus 1, a square plus 1 as a Pythagorean triplet. For example, a, putting a equals to 4 in 2a, a square minus 1, a square plus 1, we get 8, 15, 17 as Pythagorean triplet. B, putting a equals to 5 in 2a, a square minus 1, a square plus 1, we get 10, 24, 26 as Pythagorean triplet. Property 11. Between two consecutive square numbers n square and n plus 1 whole square, there are 2n non-perfect square numbers.